Hello and welcome to this short video introducing our Diagnostic Pathway Simulation Tool. The purpose of this tool is to demonstrate how demand and capacity modelling can be helpful in predicting waiting times for diagnostic pathways. At the NHS Transformation Unit, we are committed to the transparency of our work. Therefore, the code required to recreate this app is publicly available from our GitHub site. Now, before we dive into the modelling, let's look at the pathway itself. Remember, this is a simple pathway to demonstrate why demand and capacity modelling is important, so it won't be as complex as real life. However, we have included some real-world problems, such as clinical urgency or event capacity. There are two types of patients who are referred into this service. The first are our routine referrals. These patients will go onto the waiting list and they will then be seen in that order. Simply put, the longest waiter will be the next patient seen. We also have a second group of patients who are referred in for the diagnostic investigation. These are our emergency referrals and represent current inpatients who require this investigation as an emergency. Our diagnostic capacity is split between routine planned cases and the emergency cases. Emergency capacity can only be used for emergency referrals, whilst our planned capacity is used to see our routine referrals. However, if we have more emergency referrals than there is the capacity to see them, we can see these patients within our routine capacity. Once a patient has then had their diagnostic investigation, they will be discharged from this waiting list. Now that we understand how patients flow through the pathway, we can begin to use the model to test different scenarios. The first consideration is to set up the size and the shape of the current waiting list. This represents those patients who are currently waiting to be seen at the start of the simulation. We can do this by setting the number of patients that we want on our waiting list at the start. This is the size of our waiting list. We can then simulate how long each of these patients have been on the waiting list for by adjusting the mean waiting time and the standard deviations of these waiting times. The model itself uses the log normal distribution to simulate a waiting time for all of the patients who are currently on the waiting list, using these parameters that we set. The distribution of these waiting times is shown in the histogram on the right. We can amend these parameters until we are happy that the size and the shape of the waiting list is set to what we want to test in the model. In the next stage, we can then run the model itself. Now, there are many parameters we can set related to how long we want to run the model, the demand for diagnostic investigations, and the capacity to undertake them. So let's review each of these in turn. As this is a simulation model, new referrals are generated based on probability distributions. Setting the same random seed number will ensure that another user can replicate the same results with the same initial conditions. We then need to consider how long we want the model to run for. By default, this is set to 30 days, but we can increase this, for example. Let's set the model to 150. Now that we've set conditions for how we want the model to function, we can also set the parameters that impact the demand and capacity of the diagnostic pathway. The next set of inputs enables us to set the average number of planned referrals and the average number of emergency referrals that are received each day. Now that we've set those, we can also set the daily capacity for both the planned and emergency diagnostic investigations that can be carried out each day. The final parameter represents the number of days we want to set within the model to account for the time it takes to book a patient referred as a routine into a slot. For example, we wouldn't necessarily expect a patient to be available to attend the same day that they're referred. Therefore, we can set a minimum number of days between a referral and when a patient will be available to attend for the investigation. Now that we've set our parameters, the model updates and we can explore what happens during the model run. You'll see that there are two charts on the right-hand side. The top chart represents the size of the waiting list at the end of each day of the simulation. During each day, the model simulates new planned and emergency referrals and then determines who will receive a diagnostic investigation each day, dependent on the capacity available. On the first day of the model, the emergency inpatient referrals will be investigated, and the remaining planned capacity will be used to see the longest waiters, those on the initial backlog we previously set. The new routine referrals will go onto the waiting list and wait their turn to be seen. This process continues each day within the model, and we can see how the size and the shape of the waiting list changes each day, dependent on the demand and capacity available. The second chart below shows a summary of the waiting times for patients who are still on the waiting list waiting for an investigation at the end of each day. The solid amber line represents the median waiting time, and the shaded area represents the interquartile range of waiting times. We can therefore see how the waiting times change over time within the model, dependent on the parameters that we set. Another way to explore and understand what is happening within the model is to view this as a daily table of the changes to the waiting list. This table shows the number of patients starting on the waiting list each day, the new referrals, the number of new planned referrals and emergency referrals each day. Based on the capacity that we set, the number of emergency patients seen and the number of routine planned patients that will be seen. And therefore we can see the size of the waiting list changes each day based on the additions, our referrals, and the removals, those receiving the investigation. Finally, we can see the waiting time summaries for those patients still on the waiting list at the end of each day. The number of patients waiting at the end of the day then becomes the number of patients waiting at the start of the next day, and this process continues for each day within the model. Now that we understand how the model works, we can then begin to test different scenarios to understand what will happen to the waiting list if we change our demand or capacity. For example, if we increase the planned capacity from 9 per day to 11, we can see that our waiting list doesn't increase as sharply as it did previously. If we also increase our emergency capacity each day, we can see that this also has an impact on reducing the waiting list growth, as we are no longer losing some of our planned capacity to treat this overflow of emergency referrals. By testing different demand and capacity parameters in the model, we can predict how this will impact the size and shape of our diagnostic waiting list. This improves decision making on how we can transform diagnostic pathways by understanding the likely impacts. If you have found this demo helpful and would like to know more about how the NHS Transformation Unit can support your diagnostic programs, please do get in touch. Thank you for watching.